prior to forming new tissue. In nano scaffolds, cell adhesion, proliferation, and differentiation improved when compared to control scaffolds. Natural healing processes in these dense tissues are limited, as a result of the mechanically challenging environment of the damaged tissue, and the hypocellularity and avascular nature of the extracellular matrix. Freeze-dry method. Different ratios of tricalcium phosphate and gelatin are mixed in the solvent to yield the scaffold. The steps involved in preparing scaffold are as follows. 99% deionized water and 1% solvent were mixed together. Different ratios of gelatin, tricalcium phosphate, and chitosan were added to above solution. The above prepared sample is heated at 60 degrees Celsius till gelatin dissolve. Stir the sample using magnetic stirrer till the sample is mixed homogeneously. Prepare the samples of X and Y in different ratio. Keep the samples in deep freezer for 1-2 HRS so that it freezes thoroughly. Then place the samples in lyophilizer for 1-2 HOURS. Remove the sample from lyophilizer and then keep it in deep freezer. Repeat this step for 3 days. Method that we have employed to synthesize scaffold is freeze-drying method. The instrument which is used in freeze-drying method is lyophilizer. Freeze-drying works by freezing the material and then reducing the surrounding pressure to allow the frozen water in the material to sublimate directly from solid phase to gas phase. Materials used to prepare the scaffolds. Tricalcium phosphate, the inorganic component of bone, primarily consists of salts of calcium and phosphate. Above 30% of the cellular part of bone consists of the organic components, and 70% of salts. The interspersed crystals of these salts give bone its compression strength. Chitosan, a natural biopolymer, anti-inflammatory. The chitosan salts are biocompatible and biodegradable, making them the natural polymer to be used as for a structural supportive framework, alongside calcium salts. Chitosan plays an important role in the attachment, differentiation, and morphogenesis of osteoblasts, the bone-forming cells, because of its structural similarities with glycosaminoglycans, a major component of bone and cartilage. Gelatin is closely related to natural polymer. And is used as a binder. Used as binding agent for the scaffold. One of the highly biocompatible biomaterial. Acetone, which is used as a solvent for all the materials. The first picture shows while adding the mixture, and second picture shows while stirring the mixture, used for making scaffold. This picture shows, after stirring the mixture homogeneously. This picture shows, after deep freezing of a scaffold. This picture shows the structure of scaffolds after lyophyllacetone. This tabular representation shows the different ratios of tricalcium phosphate, chitosan, and gelatin with 50% of nanoparticle extract which is got incorporated in it. Designing and customization of scaffolds. K3D Surf is a program to visualize and manipulate mathematical models in 3, 4, 5, and 6 dimensions. K3D Surf supports parametric equations and isosurfaces. This is the basic cube reference design, which shows the external as well the internal isosurfaces of the cube module. This model signifies the equal dimensions, as per the length and breadth. The spherical activation site could be considered as the site of cell attachment. The negative space could be the elemental space containing nutrients to nourish the cell. Here x, y, z are the axis constants and all the dimensions are in multiples of 2, in order to give a symmetry to the figure. This model signifies the curvature of the sides as per the length and breadth. The spherical activation site could be considered as the site of cell attachment. The negative space could be the elemental space, containing nutrients to nourish the cell, which is evidently bigger than the basic cube design. Here x, y, z are the axis constants and all the dimensions are in multiples of 2, in order to give a symmetry to the figure and a constant value for the activation site in the center. This model signifies the curvature of the sides as per the length and breadth. The spherical activation site could be considered as the side of cell attachment, which are more in number than the original design, to allow an increased attachment of cells. The negative space could be the elemental space, containing nutrients to nourish the cell, which is evidently bigger than the basic cube design. Here x, y, z are the axis constants, and all the dimensions are in multiples of 2, in order to give a symmetry to the figure, and a constant value for the activation sites has to be subtracted. The applications are, movable joints. Joints where quick recovery is necessary. Possibly rib cage. The designing could be followed by rapid prototyping software. The result could be given to a 3D printer. Exact dimensional mold could be obtained. Mold could be used to synthesize the scaffold relative to that bone. Degradation analysis of the scaffolds. In vitro degradation testing. The degradation testing was performed, according to the ISO 10993-14, Biological Evaluation of Medical Devices, Part 14, Identification and Quantification of Degradation Products from Ceramics. It consisted of 2 tests. At different pH values. The first test was performed in phosphate buffer solution, pH 7.4, and is referred to as simulation solution testing. The second test was conducted at pH 3.0. Using citric acid and is referred as extreme solution testing. Tests were carried out at 37 degrees Celsius, and with a mixing speed of 120 rpm. The samples were incubated for 4, 8, 12, 18, 24, 30, 36, 42, and 48 hours for both testing solutions. The sample weight before degradation was measured as Wo. The sample weight after degradation washed by distilled water was measured and dried as Wt. The weight loss is given, the following equation. This slide shows the outcomes of the degradation on scaffolds. Porosity analysis. Measurement of porosity. A total porosity percentage was measured, following the Archimedes principle. The sample was tied by nylon string, and weighed in the air. The sample was then placed in a beaker, containing water for 1 hour. While it was sunk in the water, the sample then was weighed. The percentage of porosity value can be calculated, based on the following equation. Antimicrobial analysis. The picture shows the scaffold, with nanoparticles shows zone of inhibition. Thank you.